The May 2nd Saturday is just 20 days away. If you want to keep your score from tanking, you need to master these 5 exact problem types that just devastated students on the March test. Let's solve them right now. Problem 1 is a classic college board trap. They test your reading focus just as much as your factoring skills. Don't fall for it. A function is defined by f, x, equals 3x squared, 5x plus 2. If f, a, equals 0 and a is a positive integer, what is the value of a? First, the question tells us that f of a equals 0. So, we simply plug a in for x and set the whole equation to 0. 3a squared, 5a plus 2 equals 0. Set function to 0. Now we factor the quadratic. We need two numbers that multiply to positive 6 and add to negative 5. 3a, 2a, 1, equals 0. Factor the equation. Set that first binomial equal to 0 to find our first potential root. 3a, 2 equals 0. Set first factor to 0. Add 2 to the right, divide by 3, and we get a equals 2/3. A equals 2/3. Solve for first root. Now let's do the exact same thing for the second binomial. a, 1 equals 0. Set second factor to 0. Add 1 to both sides, and we get a equals 1. Now we have two answers. A equals 1. Solve for second root. Here is where careless students lose points. Look back at the prompt. It explicitly states a must be a positive integer. A equals 2/3 or a equals 1. Review constraints. 2/3 is a fraction, not an integer. Cross it out immediately so you don't accidentally bubble it in. A equals 2/3. Eliminate fraction. That leaves 1 as our only valid, point-scoring answer. A equals 1. Final answer. Problem 2. Word problems like this were everywhere in Module 2. Let's translate this English into a math system and smash through it. Store A sells raspberries for $5.50 per pint and blackberries for $3 per pint. Store B sells raspberries for $6.50 and blackberries for $8. A purchase costs $37 at Store A or $66 at Store B. How many? First, let's turn Store A's pricing into a math equation using R and B. 5.50 R plus 3.00 B equals Store A equation. And for Store B, we do the exact same thing. 6.50 R plus 8.00 B equals 6, Store B equation. We want to find B, so let's eliminate R. Let's multiply the top equation by negative 6.5. 35.75 R, 19.5, multiply top by minus 6.5. Now we multiply the bottom equation by 5.5. 35.75 R plus 44 B equal, multiply bottom by 5.5. Add them together, and watch the R terms perfectly cancel out. 35.75 R plus 35.75 R, add equations. Now we just have 24.5 B equals 122.5. 24.5 B equals 100 and simplify. Divide both sides by 24.5 to isolate B. 24.5 B slash 24. Divide to isolate B. And we get exactly 5 pints of blackberries. Match it to option C and move on. B equals 5. Final answer. Problem 3. Inequalities trip up so many students, but you can literally just test the answers. Let's hunt for the right point. y-4x plus 4. Which point, x, y, is a solution to the given inequality in the xy plane? Steps. We just need to plug our coordinate pairs into the x and y spots to see which one makes a true statement. y-4x plus 4. Original inequality. Let's test option A, where x is 2 and y is negative 1. Minus 1-4, 2, plus 4. Plug in, 2, minus 1. Negative 8 plus 4 is negative 4. Is negative 1 less than negative 4? Nope. Dash 1 dash 4. False statement. Let's skip down and test option D. Plug in negative 4 for x and 0 for y. 0 dash 4, minus 4, plus 4. Plug in, minus 4, 0. Negative 4 times negative 4 is positive 16. 16 plus 4 is 20. 0 16 plus 4. Simplify right side. Is 0 less than 20? Yes it is. That makes a perfectly true mathematical statement. 0 20. True statement. Option D is the only coordinate pair that works. Point equals caret, minus 4, 0, caret. Final answer. Problem 4. This parameter question caused a massive panic on Reddit. The secret? You just need the discriminant. The equation x squared, px plus w equals minus 85 has two real solutions for x. Which of the following cannot be a value of w? Steps. First, we need this equation to equal 0. Let's add 85 to both sides. X squared, px plus w plus 85 equals 0. Set to 0. To have two real solutions, the discriminant, b squared minus 4ac, must be greater than 0. b squared, 4ac 0. Discriminant rule. Let's plug in our specific values. Our a is 1, our b is negative p, and our c is everything else, w plus 85. P squared, 4, 1, w plus 85, 0. Plug in values. Simplify that down. We get p squared minus 4w minus 340 must be strictly greater than 0. P squared, 4w, 340 0. Simplify. Add the w and constant to the other side to isolate p squared. P squared 4w plus 340. Isolate parameter. Because any real number squared is always positive, the right side gives us the boundary for what w can actually be. 4w plus 340 p squared. Analyze boundary. By testing the multiple choice options here against your boundary, you instantly find the one that breaks the rule. Analyze options equals caret w boundary found caret. Final answer. Problem 5. The SAT loves hiding advanced algebra in Module 2. Here is exactly how to rip apart a cubic function fast. Let f, x, equals x cubed, 6x squared plus 9x. Find all critical points of f and determine the intervals on which f is increasing and decreasing. Steps. To find critical points, we first need to take the derivative of our function using the power rule. F, x, equals 3x squared, 12x plus 9. Take the derivative. Set the derivative equal to 0 to find exactly where the slope goes completely flat. 3x squared, 12x plus 9 equals 0. Set to 0. Let's make this way easier to factor by dividing the whole entire equation by 3. X squared, 4x plus 3 equals 0. Divide by 3. What multiplies to positive 3 and adds to negative 4? Negative 3 and negative 1. X, 3, x, 1, equals 0. Factor quadratic. This gives us our two critical x values. X equals 1, x equals 3. Find critical points. Now we test the intervals. Plug 0 into the derivative, we get positive 9. So the original graph is increasing before 1. x1 is increasing. Test first interval. Plug in 2, and we get a negative number. So the graph is decreasing between 1 and 3. 1x3 is decreasing. Test second interval. Plug in 4, and it's positive again. Increasing, decreasing, increasing. x3 is increasing. Test third interval. Here are your critical points and the exact behavior of the graph. Caret x equals